Today we're going to revisit factoring. So we're going to talk about the GCF again, but then we're going to talk about the difference of two squares, which we also abbreviate as dots, and the sum and difference of two cubes. All right. So there are many ways we can factor a polynomial depending on the terms that they have. All right. So throughout this unit, you will be asked to factor completely. This means that you may do one method or you may have to do multiple to solve the problem. It depends on that problem. Okay. So today we're going to look at three different ways: greatest common factor, which we've looked at before, and the difference of two squares, and the sum and difference of two cubes, which you may or may not have seen in Algebra 1. Okay. So the first thing we do anytime we factor is we look for the greatest common factor. Okay. So always start with this. There may or may not be a greatest common factor. Okay. But you always check for one. You can always take a 1 out, but that may not help you. All right. So you may not know that you can use another method until you do that. It may hide something else unless you take that out. All right. So what we want to do is identify the GCF. So what that means is find all common numbers, variables, or both. Okay. And then divide by the GCF to find the leftovers and write the answer as the GCF times whatever was not taken. Okay. To know that you can factor by another method, look at the leftovers. So we would look at that and say, can I do anything with that? If not, then we stop. If we can, we keep going on. So we'll practice doing a GCF while we're there. All right. So the two special factoring we're going to talk about are difference of two squares and difference and sum of cubes. So the difference of two squares or dots is another method that we can use to factor. Okay. We use it for binomials, means it has two terms, all right, that are being subtracted and are perfect squares. All right. That means it has to be able to be written as something squared minus something squared. So let me give you an example. X squared minus 4. This is x squared minus 2 squared. So those are perfect squares. I can take the square root of both of them. All right, perfectly. This would not be. So this is a no. Well, I can take the square root of that nicely. I can't take the square root of 7 nicely. All right. Okay. And it could even be something that looks like this. Because I can take the square root of that. That would be 2x, and I put a square there. The square root of 9 is 3. So I can use this. This is perfect squares. All right. There's 2 of them, and they are subtracted. They hit all 3. All right. So all 3 of those requirements must be satisfied. So a perfect square is a number whose square root is a whole number. So 1, 4, 9, x squared. Okay. So here's a list of your other ones. Okay. So here's a whole bunch of other ones if you need to refer back to. All right. So like I said, we want to be able to write it as a squared minus b squared. All right. So in order to do this, here are your steps. Get rid of a GCF if there is one. We have to get rid of that GCF. Identify A and B by taking the square root of both terms, but don't include the negative. Leave the negative in the middle. And then here is your formula. Okay. Plug A and B in the formula of A plus B times A minus B. All right. Note that it doesn't matter if you put the plus first or the minus first. It doesn't matter. They are the same thing, right? You just have to have an A plus B and you have to have an A minus B. Okay. And then you'll need to check to see if either factor can continue to be factored. So if it's like x plus 2, there's nothing else I can do because it's linear. All right. All right. So we're going to practice that. So a squared minus b squared is a plus b times a minus b. All right. That's one of the formulas you're going to need to know. You're not always given those on tests and quizzes and things like that. And on some standardized tests, you're not given them. Some you are, some you aren't. All right. Okay. All right. The sum and difference of two cubes. So you notice for squares, it had to be minus. For cubes, it can be adding or subtracting. It has to be two terms, just like these, and it could add or subtract. It could be perfect cubes. So it could be in the form a cubed plus b cubed, or a cubed minus b cubed. Okay. So perfect cubes are things that you can take the cube root of. So 1, the cube root of 1 is 1. Cube root of 8 is 2. The cube root of 27 is 3. And the cube root of x cubed is x. Okay. Note, any variable with an exponent is divisible by 3 is a perfect cube. So as long as the coefficient is a perfect cube, you can do it. All right. So here are some perfect cubes to keep in mind. All right. And then here's how we solve it. So we factor out the overall GCF if applicable. Okay. And then what we want to do is write it as a cubed minus b cubed. We leave the negative here if we have that, right? Don't include that negative, just like we did in above. And here are the two formulas. Okay. I want you to notice that they are very similar. There's only two differences in the formula. This has a plus here. This has a minus. This has a minus. This has a plus. Okay. Otherwise, the formulas are exactly the same. And how do you know? This one is the same, and this one is opposite. Okay. All right. So the first one is the same. This one's opposite. This one's always positive. Okay. So there's a little acronym. It's called SOAP. First one has the same sign. The second sign is opposite. And then the last one is always positive. Okay, so if you can remember the SOAP. So if you know the top formula, you know the bottom one. You just switch those first two. Okay. First one has to match, and then the second one doesn't. And the last one's always plus. Okay. All right. So I'm going to show you how to use those as we get to them. All right. All right. So let's go ahead and work some of these problems. So first thing I'm looking at is number 1. So I'm going to look for a GCF. Well, that's an x squared. There's no x, so I'm not taking any x's. But 4 divides both of these, right? So if I divide this by 4 and this by 4, so I'm going to put that 4 outside of parentheses. This gives me x squared minus 4. So the GCF there was 4. So this was the GCF right here. Okay. Now, let's look at the second one, the x squared minus 4. So I can take the square root of x squared. That is nice. So square root of x squared is x. And I can take the square root of 4, and that's nice, right? So that means that this is x squared minus 2 squared. Okay. So we're going to use our formula. All right. So our formula is for this. So a squared minus b squared is a plus b, a minus b. This is a and this is b. The things you take the square root of, those are a's and b's. Okay. So this would be 4 is this guy. And this would become x plus the 2 and x minus the 2. And if I look at that, I can't do anything with the x's. Right? It doesn't factor anymore. So we are done because it is linear. All right. Once you get down to the linear, there's nothing else we can do. You notice if I tried up here, I could also do the difference of squares, but I want to take any GCF out first. All right. Okay. All right. So let's look here. This has a GCF of at least x, right? 2 and 17. No, there's no way. So I'm just going to take the x out. Divide everybody by x. So that's x squared plus 17x minus 2. So that was the GCF. Now, today we're talking about 2 terms. So this isn't going to factor, but next class we'll talk again about 3 terms, and that could factor. This one doesn't. All right. So we are done right here. Okay. All right. Let's keep going. So here I got a 36x cubed minus 49x. First, look for any GCFs. All right. 36 and 49, there's nothing I can take out, but I can take an x. So I'm going to take the x out. This will leave me 36x squared and a minus 49. Okay. So now if I look at this, it's got square and a minus. So I think it might be our formula. So let's see. If I take the square root of 36x squared, that's 6x. Yes. If I take the square root of 49, that is 7. So yes, that works. So this is 6x plus 7 and 6x minus 7. So that's what this looks like fully factored because I used that formula again. And it was a difference of squares. So that's why I did it. All right. So let's look at this one. This one has x's. This one doesn't. So there's no GCF. The 1 and the 16, nothing I can take. All right. So can I take the square root of x to the 4th? Yes, I can. That's x squared. Can I take the square root of 16? Yes, I can. That's 4. So I'm going to use that in my formula. This is A. This is B. So this is going to be x squared plus 4 and x squared minus 4. All right. So if I look at this, it's got the x squared, but this has got a plus. So there's nothing I can do with this one. Ooh, but this one's got an x squared and a minus. So let's see if we can do this again. So can I take the square root of x squared? Yes, I can. Can I take the square root of 4? Yes, I can. So this one, I have more work to do. So this x squared plus 4 doesn't change, but this I can turn into x plus 2 and x minus 2. So do you see how we had to keep factoring until it was fully factored, until you couldn't factor it anymore? So I had to use the difference of squares twice. All right, so let's keep going. So this has got a square and a minus. So can I take the square root? Yep, that's 9 and x. I can take the square root of 1, that's 1. So this factors into 9x plus 1, 9x minus 1. No squares, no cubes. I can't do anything else. So we are done. All right, so let's keep going. Let's look at number 12. So GCF 15 and 120, those can divide. So I'm going to take the 15 out. 120 divided by 15 is 8. Okay. Oh, I've got a cube. So remember, I have two formulas for that. I've got a cubed plus b cubed and a cubed minus b cubed. So I have a plus. So let's see if I can take the cube root of those. So cube root of x cubed, well, that's x because the root and the 3 cancel. The cube root of 8 is what number times itself? That would be 2 times 2 times 2, which is 2. So this is my A and this is my B. Okay, so this is a sum of cubes. So according to this formula, it's A plus B. Take the A squared minus A times B and then add the B squared. All right, so I'm going to show you how to use this formula. So here's the 15. All right. So this one says take x plus that 2. So I'm going to take the x plus the 2. That's the first parenthesis. Then this one says take the first thing and square it. So take x and square it. Well, that's x squared. Minus, right? It says minus. And then it says multiply a and b. Well, here they are multiplying. So 2 times x is 2x. Plus, then it says take the b and square it. So I'm going to do 2 squared, which is 4. Okay. And this rarely factors, so we are done. Okay. That's how that formula works. And again, that's just a formula you want to remember. All right, so let's keep going. So if I look here, let's see what we can take out. 14, 21, 30. Oh, I can take a 7 out of all of those. Okay. I have 4, 6, and 5. So I can take 4 x's because you have to take the smallest number, right? Because you have to be able to take enough out of everybody. So divide 14 over 7 is 2, and I took all the x's. Minus 21 over 7 is minus 3, and I took all but 2 of the x's. And then 35 over 7 is 5, and I'm leaving 1x. Okay, so that will work. I'm going to rearrange and put the x squared first. Okay. Now, if the front one has a negative, you could have taken a negative out. So I'm going to go ahead and do that. So this would be negative 7x to the 4th, and it would just change everybody in here. All right, So can we factor this? So this actually does factor more, okay? But we're going to talk about that next class. So we're going to stop here for today. But after next class, we're going to be able to continue factoring. This one factors. So just put a little note that it would factor more, okay? After next class, you'll be able to get it to here. This would be that. Okay. If you remember how to factor those, you could factor it and get there, okay? But there aren't going to be any on the assignment today, all right? Or next class. All right, let's keep going. So no GCF other than 1. Ooh, I have cubes. All right, so let's make that cubed. So cube root of x cubed is x. Can I take the cube root of 125? And so if you look at our list, that is 5. So here's A, here's B, right? Okay, so basically you're saying this is x cubed plus 5 cubed, okay? All right, so let's plug into the formula. So our formula for this one, I'm going to write it down. No. Okay. So it would be x plus 5, because A is x. Then square that, so that's x squared, minus multiply those two. So that's 5x plus square that one. That's 25. And there you go. We have factored it. Okay. Well, let's keep going. So the GCF on these is 1. Okay. So I'm going to see, can I take the square root of those? Because I have squares. And yes to both, right? This is 6, and this is 9x. So this would be 9x minus, oh, wait a minute. Both of those are divisible by 3. So let's go back. So, oh no, I missed a GCF. I can take a 9 out. So this would become 9x squared minus 4. Ooh, so don't forget your GCF there. Okay, so this 9 is going to stay there. But now, square root of 9x squared is 3x. Square root of 4 is 2. So now it's going to be 3x plus 2, 3x minus 2. So don't forget your GCF. Okay. All right. So I want to skip around a little bit after we do 2, 3. Oh, these numbered weird. So that's 4 because it goes 1, 2, 3 down the column. All right, whatever. So look at x cubed minus 8. All right. So we've got cubed. So I'm going to take the cube root. I'm going to take the cube root. So this is x. This is 2. But this time we have a minus in between. So the formula changes. Remember, same, opposite, always positive. Okay, so that's what we're going to plug into. So this one's going to be x minus 2 times x squared plus, multiply them, plus last one squared. There you go. Okay. Let's jump all the way down to number 15 here. Okay. So 8 and 125, there's nothing I can divide. You notice that cube. So can I take the cube root of 8x? Cube root of 8 is 2, and the cube root of x cubed is x. Cube root of 125 is 5. So this is my A, and this is my B. All right, so remember how the formula works. It's A minus B, A squared plus AB plus B squared. Okay, I wanted to do one because that's what people mess up. All right. So it's going to be 2x minus 5. So this one says A squared. That's 2x squared. You have to square both of them. So 2 squared is 4, and x squared is x squared. Plus, multiply them. 5 times 2x is 10x. And then 5 squared would give me 25. All right. Okay, we'll practice some more in class.